Okay, starting chapter 3. And the first section is on what are called quadratic functions. And the first thing we get is the definition of a quadratic function. And it says, let A, B, and C be real numbers with A not 0. Then the function f of x equals ax squared plus bx plus c is called a quadratic function. So maybe you remember the quadratic formula. Quadratic function, quadratic formula. Quadratic formula, you have to have a function that looks like ax squared plus bx plus c. The graph of a quadratic function will be a parabola. If a, the number in front of x squared, is greater than 0, which is just the same as saying positive, then the parabola will open up. So it'll look like this. If a is less than 0, which is negative, then the parabola opens down. So it would look like that. The highest or lowest point on the graph of a parabola is called the vertex. So like in the graphs I just drew, you would look for either the highest or lowest point. So parabola has a few different important points. So the y-intercept is an important point. The x-intercepts, if there are any, it is possible that a parabola will not have any x-intercepts. And the vertex. So the y-intercept and the vertex. So it always has these. It may not have x-intercepts. Another important feature of the graph of a parabola is called the axis of symmetry. And the axis of symmetry is the vertical line that passes through the vertex. So like if our parabola opens up, the vertex is the lowest point on the graph, and the axis of symmetry is the vertical line through that. It's like the line that cuts the parabola in half. We find the x and y intercepts as we always have. For the x-intercepts, we plug in y equals 0. That's for x. And for the y-intercepts, we plug in x equals 0. What's called the standard form of a quadratic function is the formula that looks like that. So a times, and then parentheses, x minus h, whole thing squared, plus k. So that first half, we saw that in the standard form for the equation of a circle, right? The x minus h squared plus y minus k squared equals r squared. In the circle, the letters h and k were for the center. For a quadratic function, that we use that standard form to find the vertex. So you set what's in parentheses equal to 0, solve for x. That's the x coordinate of your vertex. So here in the x minus h, which is inside parentheses, if you set that equal to 0 and solve, you get x equals h. And then whatever number is on the end, that's your y coordinate. And it could be positive or negative. If the function is not in the standard form, it's in the like multiplied out form, we can still find the vertex as follows. So the h is negative b over 2a. And if you remember the quadratic formula, x equals negative b plus or minus square root b squared minus 4ac all over 2a. It's right there in the quadratic formula. It's just you leave off the plus or minus square root part. It's the negative b over 2a, just that part. So that's how you find, that's the x coordinate of the vertex. So we find k, which is the y coordinate. By plugging that number into the function. When I say that number, I mean the h. The negative b over 2a. You plug that number in to the function for x. Oops. So whatever we get, that's our k. So k equals f of h. If we are given the parabola in that form, the like multiplied out form, and are asked to give the standard form, in the standard form, that's what we had above, f of x equals a times x minus h squared plus k. You can either use completing the square, and that might be what the book walks you through, doing completing the square, or how I do it is I just use those formulas above. H equals negative b over 2a. So that's what goes in parentheses, x minus whatever that number is. The a that's out in front of the parentheses is the same number that's in front of x squared. So the a doesn't change going from one form to the other. Then we can use the formula to find the h, and then we can plug in whatever number we get for h to the function to find our k, and that's what goes on the outside. And we'll see examples of that. Okay, so here I give us a quadratic function, and we're asked to do three different things, although the first thing asks for a lot. Give all the intercepts, the coordinates of the vertex, the axis of symmetry, and sketch the graph. Afterwards, state the domain and range, and then write the standard form of the quadratic function. Okay, so let's just start with part A. And I like to do the y-intercept first, just because it's the easiest. For the y-intercept, remember, we just plug in x equals 0. So remember, we're plugging them in there for those x's. So I just have 0 squared minus 4 times 0. Well, that's just 0 minus 0, which is 0. So that's the y-intercept. The x-intercept, we plug in y equals 0. But remember, f of x is just another name for y. So we put a 0 in where the f of x is. So on the left-hand side, 0 equals x squared minus 4x. And then whenever there's an x squared, we want 0 to be on the other side. I don't want to add the 4x to both sides. Keep it as 0. What you want to do instead is factor. Well, I see both of those terms have an x in common, so I can factor out x. And we'd be left with x minus 4, and then set each of those things equal to 0. So we get x equals 0, x minus 4 equals 0, add 4 to both sides, and you get x equals 4. So those are the two x-intercepts. This was the y-intercept. Okay, now the vertex. This one is not in standard form because we don't have parentheses squared. So it's h equals negative b over 2a is the formula. And in this problem, the a is the number in front of x squared. So a is 1. B is the number in front of X, so B is -4. And we don't really need C, but if we were using the quadratic formula, we would say C is 0. There is no just number being added on at the end. Okay, so negative B is -4. So I have -4 over 2 times 1. Well, negative, that's positive. So I have 4 over 2, which is 2. Okay, so there's my H. H is 2. And then the K is what I get when I plug 2 into the function. So I would have 2 squared minus 4 times 2. So that would be 4 minus 8, which is -4. The vertex is a point, H, K. Okay, so now we found the vertex. Axis of symmetry. So the axis of symmetry is the vertical line that goes through the vertex. And if you remember, so if we go back and look at our notes from the section on lines, we talked about when we have a vertical line, the equation looks like X equals a number. And so it's going to be a vertical line, so it's going to be X equals, and it's just the X coordinate of the vertex. So it would be X equals 2 in this case. And then it says sketch its graph. So I'm just gonna plot all the intercepts. So let's see, the y-intercept was 0. Oops. The x-intercepts were 0. Okay, I've already plotted that, and 4. And the vertex is 2, -4. One thing I'll make a note of right here is if there are 2 x-intercepts, and there won't always be, your vertex better be halfway between them. It's because of symmetry of them. So when I saw I had x-intercepts at 0 and 4, I actually knew my vertex better be like right in the middle, which would be at x equals 2. And then we can go ahead, if you want, you can plot more points. You can, like, if say you want to plug in x equals 5. So one other point. And I want to show you how you can use symmetry with graphing. So if x equals 5, then y equals, we just plugged 5 in for x in the formula. So 5 squared minus 4 times 5. So it would be 25 minus 20, which is 5. So one other point on the parabola would be 5, 5. Okay, so here's x equals 5, halfway between 4 and 6, 5. Now remember, the axis of symmetry cuts the parabola in half. So it goes, it's that vertical line right through the vertex. And so I should have the mirror image of that point I just plotted, 5, 5, on the other side. So let's see, if this one went right 3 units from the axis of symmetry, then there should be its mirror image left 3 points from the axis of symmetry. I knew my parabola should open up because my A was positive. Okay. So I have everything answered for part A. The intercepts, the vertex, the axis of symmetry, sketch its graph. Afterwards, state the domain and range. So part B, domain, range. So remember, when we're looking for the domain, we just have two things to worry about. No negatives under a square root, but when I look at that function, there's not a square root in there or fourth root or anything. You also can't have 0 in the denominator. Well, there's not even a fraction, so there's no denominator. So the domain is all real numbers or negative infinity to infinity. So just to note, this is always the domain of a quadratic function. So the domain is always all real numbers for a quadratic function, unless they start out at the beginning saying x is greater than or equal to 0 or something. But if they don't make any restrictions on x, that's always the domain. The range, remember, you go lowest to highest. So for this graph, the vertex is the lowest point, right? So right here, that's the lowest. And that y is -4. There is no highest point. That parabola opens up, it's going to keep going up forever. So it's to infinity. Okay, and then part C says write the standard form of the quadratic function. So part C, the standard form looks like f of x equals a times x minus h squared plus k. And our a is the same between both forms. And we already set up here that a was 1. So we know a is 1. H is the x coordinate of the vertex, which was 2. And k was the y coordinate of the vertex, which is -4. So I'm just plugging everything in. So I get f of x equals, you can write the 1 there or not. You can just leave off the 1 and just write it as x minus 2 squared plus -4. You could write it like that, or you could just write it as -4. I am not going to do this, but I am going to make a note is that you can always check with FOIL. You multiply out, combine like terms, and you should get the equation that it started with. So if you do FOIL, combine like terms, you should end up with x squared minus 4x. If you don't, you've made a mistake. Okay, same steps, but with this new function. So the first thing, though, is still find the intercepts. So I'll start with the y-intercepts, which is just where we plug in x equals 0. So I get y equals, well, -3 times 0 squared is 0, plus 3 times 0 is 0, minus 2. So I get y equals -2. For the x-intercepts, we plug in y equals 0, but f of x is the same as y. So I'd have 0 equals -3x squared plus 3x minus 2. This is one I don't think I can factor. Yeah, you can try, but there's no way to factor this one. So we'll have to use the quadratic formula. So I'm going to identify my A, B, and C. So my A is -3. Oh, and that tells me that when I graph my parabola, it's going to open down. B is +3 and C is -2. I like to do the part under the square root first, which is b squared minus 4ac. That's called the discriminant. I'm never going to test you on that, but you might see it in the book. Okay, so b is 3, so I'd have 3 squared minus 4 times a is -3 times c is -2. So what do I have? 9 minus 4 times -3 times -2 is +6. So I'd have 9 minus 24, which is -15. But this is under the square root. And if we take the square root of a negative number, we don't get a real answer, and everything on the x-axis is a real number. So this has no real solution, which means there are no x-intercepts. And remember, I said that could happen. You will always have a y-intercept, you will always have a vertex, but you might not have x-intercepts. Okay. Let's find the vertex. So the h, which is the x coordinate, is -b over 2a. And b is 3, so I have -3 over 2 times a is -3. So you would end up with -3 divided by -6. Well, negative divided by negative is positive. And 3 over 6 simplifies to be 1/2. Okay, so there's the x coordinate of the vertex. Now we have to find the y coordinate of the vertex, which is called k. And we plug that value of x, 1/2, into the function. So I had -3 times 1/2 squared plus 3 times 1/2 minus 2. Okay, so when I square 1/2, you just square the numerator, square the denominator. So I get 1/4. Okay, let's think of this 3 as being 3/1. And in the next step, I'll think of that as also being -3/1. So let's see. Plus, if I multiply those together, I get 3/2 minus 2, which I'm also going to think of as being over 1. So k is -3/4 plus 3/2 minus 2/1. So the lowest common denominator is 4. So the first fraction, I'll just multiply numerator and denominator by 2. And the second one, I have to multiply numerator and denominator by 4. So I get -3/4 plus 6/4 minus 8/4. So -3 plus 6, that's +3 minus 8. So that would be -5/4. Okay, so now we can say what the vertex is. Vertex is the x coordinate was 1/2 and the y was -5/4. And then I think they asked us to find the axis of symmetry, and it's always x equals a number because it's a vertical line, and it's the x coordinate of the vertex. So the axis of symmetry will be x equals 1/2. Okay, so let's plot everything we have so far. So the y-intercept is -2. There are no x-intercepts. The vertex was 1/2, -5/4, which is -1 1/4. Okay, so 1/2 would be right here, and then -1 1/4, about right there. That's all we have so far, and the axis of symmetry, which is the vertical line through the vertex. But remember, so if like the axis of symmetry kind of acts like a mirror, so that y-intercept at 0, -2 should have a mirror image on the other side of the axis of symmetry. So there will be another point just right over here. I think I'm going to plug in one more value. Let's plug in x equals 2. So another point. So if x equals 2, then y equals -3 times 2 squared plus 3 times 2 minus 2. I think that's right. Wherever I have an x, yep, -3 times 2 squared plus 3 times 2 minus 2. So I have -3 times 4 plus 3 times 2 is 6 times 2. -3 times 4 is -12 plus 6 minus 2. So -12 plus 6 is -6 minus 2 is -8. So the other point is 2, -8. Okay. So 2, -8. But then by symmetry, I'll have another point just on the opposite side of the axis of symmetry. So this one went over, so it went to the right 1.5. So I should go to the left 1.5. Oops. And then just connect the dots. And we knew it should open down because the A was negative. Okay. That was just part A. Part B was, I think, find the domain and range. So I've already mentioned before that the domain for a quadratic function is always all real numbers. The range, we have to go lowest to highest. And so when the parabola opens down, the lowest part, it's going down to -infinity. The highest part is at the vertex. And the y coordinate of the vertex, we see just 2 lines up, is -5/4. So that would be the highest y value. And then part C was write it in standard form. Remember, standard form is f of x equals a times x minus h squared plus k. And we already know that our a is -3. We use that in the quadratic formula, right? Our h is the x coordinate of the vertex, which is 1/2. And our k is the y coordinate of the vertex, which is -5/4. So putting all that together, I get f of x equals -3 times x minus 1/2 squared, either plus -5/4, I would accept that, or you can write it as -5/4. Okay, I'll do one more problem and then I'll do the rest of it in a part 2 video. So here, they give us the graph and they want us to come up with the function. And it's probably easiest to do it in standard form. Oops, x minus h squared plus k. Because the h and k, remember, are the coordinates of the vertex. So the vertex is hk, and I can tell just from looking at the graph that the coordinates of the vertex, well, the x is -2 and the y is 6. So our h is -2, our k is 6. So let's go ahead and plug at least that much in. I still don't know what a is. I know it's going to have to be negative since this parabola opens down. So I'd have x minus -2 plus 6. So I would write that instead of minus negative, I'm just going to write it as x plus 2 squared plus 6. We still need a, but I see there that they have marked a point on the graph. So that means we should probably use that point. So the x coordinate of that point is -4 and the y is -2. So I'm just going to plug those in for x and y, but remember f of x is another name for y, and then I'll be able to solve for a. So in place of f of x, I'm putting the y, which is -2 equals a, and then in place of x, I'm putting -4. Okay. So order of operations, simplify inside parentheses first. So -4 plus 2 is -2. Okay, the next thing to deal with is exponents. So we'll have to square. -2 squared is +4. I'm wanting to solve for a. So now, I mean, you can do a times 4, right? So that would be, there's the multiplication. So that would be 4a plus 6. Now I'm going to have to subtract 6 from both sides. I'm trying to solve for a. So -2 minus 6 is -8 equals 4a. And then divide both sides by 4. And you get a equals -2. So the answer is f of x equals, so -2 times x plus 2, right? The -2 is the only thing I didn't know. I had everything else from the function figured out. So x plus 2 squared plus 6. If you wanted to multiply it out completely, that's fine, but you can also leave it like this. Okay, I'll pick up with the next problem in the part 2 video.